I'm joined today by 3 analysts from Dell'Oro Group, and we will be discussing areas of innovation across the radio access network, backhaul, and core. Let me start by introducing our panelists. We are joined by Chris Dupuis, Vice President of Carrier IP Telephony, Enterprise Edge, Wireless LAN, and Wireless Packet Core Market Research Programs for Dell'Oro Group. Stefan Pongratz, Director of Mobile Radio Access Network Market Research. And Sheen Umeda, Vice President of Carrier Ethernet Mobile Backhaul and Routers Market Research, all from Dell'Oro Group. Our topic today is the next generation network, and RCR has a special report released today in conjunction with this webinar. A few takeaways from the report. Technological innovation is happening across the RAN, backhaul, and core as networks transition to all IP LTE environments. Some of the most highly anticipated technologies, such as small cells, still have challenges associated with them, either technological or operational. The process is a long evolution, but 2013 is reflective of some major milestones. This report can be downloaded from RCR Wireless News. And so now I would like to hand it over to Stefan so we can get into the slides.
All right, thank you, Kelly. Why don't we go to the agenda slide? All right, so we will start with a quick overview of the mobile broadband drivers, and then we will go in and talk about some of the specific trends in the RAN, backhaul, and core, and then followed by a Q&A session. Why don't we go to the mobile broadband driver slide. Next slide, please. So the industry has come a long way since the smartphone market started accelerating in conjunction with the launch of the iPhone in 2007. If we look at the number of mobile broadband subscriptions, they have increased more than fourfold between 2009 and 2012. And as many of us know, mobile data traffic has grown at a rapid pace, both in the licensed and unlicensed spectrum. Now, this has been driven by the availability of innovative, affordable devices, a thriving application ecosystem, coupled, of course, with improved network performance. Now, going forward, we believe that the increased expectation of the end user, not only to be connected at anywhere, anytime, but also to have the ability to use any application at anywhere, anytime, which essentially is the equivalent of saying excellent throughput and latency at anywhere, anytime. This, coupled with the improved visibility into data-related KPIs for the end users, as well as regulatory requirements to improve mobile broadband coverage. I mean, together, we believe all of these drivers will continue to challenge the managing data portion for everyone in the ecosystem to ensure that the network can handle the traffic, adapt to changes in usage patterns, that efficiency is maximized, and in the end, that the end users are satisfied. Because if we look to, let's say, Ericsson's latest mobility report, some data points from that was more than half of the smartphone users experience problems on a weekly basis. Many of the most frequent smartphone users don't perceive that the network is meeting expected standards, and network performance is the largest contributor to service provider loyalty. So in other words, we've come a long way. Service providers have a much better handle today than they did right after the iPhone was introduced when it comes to dealing with data growth, but there's still plenty of challenges and opportunities ahead when it comes to managing and monetizing data, as we're still in the very early phases of this mobile broadband transition. I mean, I think global smartphone penetration was still below 20% at the end of 2012. Just to give a reference there. Okay, that was a high-level overview, and I will now, let's now turn to the next slide, and I'll go over some of the RAN-specific trends. So the multi-mode base station was introduced in 2008-2009. There's been a lot of developments and enhancements on that base station since then, but there's still a large amount of base stations that have not been upgraded, and as a result, network modernization has been a major driver of RAN investments globally, as service providers have been looking to capitalize on these more compact base stations to reduce energy consumption and OpEx and improve radio performance and improve quality. capacity and to basically ensure that the networks are future-proof so that they can, when the time comes, be evolved from GSM to HSPA or HSP plus to LTE in the future. Okay. Within the macro network, we are seeing momentum around these so-called antenna-integrated radios that can replace the antenna and radio for each sector, essentially resulting in fewer components at the site. And there's some other benefits too, that in terms of our improved RF performance and shorter installation time, etc. Also, probably we should address here. I mean, the shift from 2G to 3G and the 3G to 4G have improved spectral efficiency, and the data we're seeing from the vendors and operators is that the majority of the sites, they still have pretty good capacity utilization, and there's good capacity levels, but there's this asymmetric data distribution that is the problem, and has resulted in very high traffic increases in a small portion of the sites. And it's in these sites we have seen an increased use of small cells operating in the unlicensed spectrum or SP Wi-Fi to complement the network in these high traffic areas. Now going forward, we have some data outlooks in terms of data traffic, so it's important to not only look at the aggregate data here, and again look at the asymmetric data distribution. And so in these high traffic areas where it might be more like 15 to 20x data growth versus, let's say, 4 to 6x in all the other sites, we believe that there will be all kinds of different solutions will be required to deal with these situations, including macro layer quality improvements, site densification, additional RF carriers, various forms of carrier aggregation, and we might also start seeing some higher order MIMO, 6-sector solutions. So we don't think there will be just one that can solve everything in those high traffic areas. And in addition, of course, we envision that operators will continue to leverage the unlicensed spectrum in the forms of small cells, and also eventually start improving spectrum utilization in the licensed spectrum. Okay, let's actually go to the next slide, and I'll talk quickly about some of the status of RAN investments. The first thing here I should probably clarify is this slide shows RAN revenues and revenues of related equipment. We measure hardware and software associated with the equipment, so it does not include any services revenues. Okay. The first point is that total infrastructure revenues for RAN and related equipment were lower in 2012 than they were in 2008, even as mobile data traffic has roughly doubled every year. And the second point I want to make is that, and which might be more related to the topic at hand here, is that LTE-related infrastructure investments are growing rapidly. It is now about 2.5 years since Verizon Wireless and NTT Docomo launched LTE networks, and we're already hitting milestones that took 3 to 4 times longer with 3G to reach. I mean, for instance, there are now 100 million LTE subscriptions. We estimate that there aren't that many, and it took about 8 to 9 years to reach similar levels with WCDMA. And we can see the same thing if we look at the number of networks that have been launched, and if we look at also the overall LTE RAN revenues. And I think it's fair to say that the shift from 3G to 4G has been a bit faster than many expected, including myself, actually. But now going forward, we just need to keep in mind that 80% of the LTE subscriptions reside in 3 countries, and the whole world is not made out of early adopters. Okay, I'm now going to hand over to Sheen, who will discuss some of the backhaul trends.
Thanks, Stefan. So I'm going to talk about mobile backhaul trends and looking at really the infrastructure behind moving traffic from the RAN to the core and eventually maybe to the internet or IP backbone IP networks. So we're looking at the drivers of mobile backhaul equipment deployed into infrastructures, we're looking at two sets of drivers. On one hand, we have network coverage and traffic growth driving the need for more equipment into the networks. RAN expansion, as Stefan talked a little bit about, some of the trends there, is increasing. On one dimension, we're seeing networks, the RAN and the subsequent requirement for backhaul expanding from a geographic perspective, covering more area. And in another dimension, we're seeing an increase in density, or more radios in any given area requiring additional connections for backhaul. From a traffic growth perspective, obviously a big factor in expanding backhaul networks and the capacity on the different links, the growing number of subscribers and devices, compounded by the increase in bandwidth per subscriber as services move from 2G, 3G, and ultimately to 4G. And then we're seeing a lot more of everything becoming data, whether it's voice, messaging, and traditional internet-type traffic. The other area behind the mobile backhaul equipment market drivers are changes in technology. We're seeing a number of factors there. One of the more obvious or the most dynamic part of the market is the transition from voice-oriented technologies in backhaul networks to data-oriented technologies. We're seeing TDM and ATM infrastructures that were great for voice being replaced or upgraded to IP and Ethernet infrastructures, meaning a number of equipment classes being displaced. TDM optical equipment, for example, moving to Ethernet-based transporter layer 2 and 3 equipment that handle IP and Ethernet much more efficiently. A second type of transition we're seeing in technology is the physical medium. Copper is ubiquitous in many parts of the world. We're seeing migrations and transitions to fiber-based technologies, or in some cases, or in many cases, to microwave technologies, taking advantage of the greater bandwidth or greater capacity that the different mediums offer over the traditional or the legacy copper infrastructures. Within microwave, we see higher capacity links, and as well as the transition from TDM to IP and Ethernet protocols. A second part of or another set of technology changes is the shift to layer 2 and layer 3 technologies. That's driven by some of the requirements of the RAN as it goes from 3G to 4G. For example, moving from logical star topologies to a logical mesh topologies. Additionally, we see this change in the network putting more layer 2, layer 3 network intelligence further out into the network. In fact, we see a lot more IP devices, routers, and switches being deployed all the way to the cell sites where they traditionally have been, or historically been, more into the core and center of the network. Going to the next slide, we'll take a quick look at some of the trends here in terms of the numbers in terms of equipment and traffic growth. So the bars on this slide represent the backhaul equipment, mobile backhaul equipment market, broken up by some of the categories I just talked about. The bottom two sections, copper, fiber, microwave, represents a physical medium. You can see that part of the market is growing, and then the top part you can see the routing, switching, or the layer 2 and 3 technologies part of the backhaul market also expanding. Over the next 5 years, we see this as a $40 billion opportunity, and it's clearly an area where a number of manufacturers are investing, and we're seeing global interest and plans for deploying this type of equipment. The last piece of this chart is the line which represents or shows the exponential growth of mobile traffic across all parts of the network. In fact, it's a very large number, or growth estimated at roughly 60% compounded annual growth rate over the next 5 years. That's the quick overview on backhaul, and I'll now let Chris talk about the core.
Thank you, Sheen. This is Chris speaking, and I will address the trends that are occurring in the core of these networks. The presentation is going to be broken into two pieces. I'll be discussing voice core and then packet core. So let me make some preliminary comments on voice core. First of all, voice traffic is growing. It's just that data traffic is growing much, much more, as Stefan and Sheen had talked about. Since the adoption of the smartphone, we've seen data take off, and this has driven much of the packet core infrastructure spending needs. What also here is important is we're still seeing net positive subscriber adds, which is the primary reason for voice traffic growth. And I also want to begin the presentation by talking about the fact that we are now seeing the early signs of a voice network upgrade towards voice over LTE. And I'll be addressing that a bit more in the next slides. Packet core, what we're seeing now is 3G-related spending is flattening, and evolved packet core, which relates to LTE, is growing. Now, we've advanced to slide 12, so I will address slide 12 now. I apologize. Okay. Carrier IP telephony is the first topic here. You can see here what's happening. Voice only, these are the blue areas. This is basically feature phones and featureless phones. This market is essentially headed into decline as the smartphone and tablets and such has taken off the other two subscription types. So we're seeing growth in data and not very much voice growth. And down on the bottom, just to put in magnitude the subscriber counts that we are expecting voice over LTE to represent as a proportion of total, you can barely see the line. It's perceptible but important because this is a growth area for the voice industry, and it is just beginning. In fact, what we had seen is in 2011 we saw the first signs of wireless IMS spending in advance of voice over LTE subscribers being brought onto the network. With that, I'd like to ask to go to the next slide, please. Okay, so here are the revenues for the voice industry, the voice core industry. You can see we have gone through three technology shifts. Circuit switch, as probably everyone on the phone knows, is essentially that trend is over and gave way to what at the time was called next generation networks. Soft switches, media gateways, devices of that type is also is now in a declining revenue trend, and we now have a new class of devices which are based on Internet Protocol and IMS technology. These are the growth areas. But what historically has driven the voice industry is net adds, and net adds to wireless networks peaked long ago. We still are seeing positive net adds, but nowhere close to what we had seen 5 and 6 years ago. So it's our expectation that while we will have net additions to the mobile networks, it's not going to be enough to stimulate revenue growth as it had in the olden days. Let's please advance to the next slide. Okay, this is the exciting part of the core, in that it's growing in revenue terms quite significantly, the wireless packet core. Wireless packet core we track in two different ways. The traditional packet core, these are the hardware and software elements in the core of the network that relate to 3G networks and 2G networks, CDMA, WCDMA, things of that nature. And then the top part of the projection and actuals that I'm showing here on this chart relates to LTE, or the evolved packet core. Pretty much all of the growth that we expect in the future relates to LTE build-outs. Now, what's interesting here is in 2012, we actually had a pause in the revenue growth for the packet core market. Why is that? It doesn't make sense, actually, because evolved packet core and LTE is growing, but what we saw was something of a pause as service providers temporarily focused their attention on building out LTE radio coverage, and you can see that in the number Stefan was pointing out. Now that we have very significant growth in LTE subs, it's dragging along, or pushing along, let's say, the evolved packet core, and we expect a sustained growth trend from there. Okay, please advance to the next slide. Okay, this is my last slide, and the point I'd like to make on this is that there is a device within the evolved packet core that is subscriber facing. In other words, the number of licenses on these devices scales with the number of subscribers in the network. And we've got a chart here that shows quarterly session shipments or licenses that illustrates that this is not just a North American phenomena, LTE rollout, but it is now spread around the world. In other words, these devices are being built to satisfy LTE demand around the world. And you can see it's pretty well geographically distributed. Now, I'd also like to leave on one point. We are seeing some new trends that are just emerging today in the core, and these relate to virtualization of the elements, as well as the additional traffic driver of service provider Wi-Fi. These two trends are likely to emerge as result in architectural changes in the core, as well as new drivers. Okay, with that, that's the end of my formal presentation, and we are ready for Q&A.
Okay, great. Going to hang on just a second. Chris, since we ended with you, I would like to go ahead and start with the questions with you. One thing that I want to touch on a little bit more is VoLTE. And I wonder if you can talk to us a little bit about why service providers are planning to make VoLTE investments and whether or not they're going to make money from those investments. We've heard a lot lately about, we did have some VoLTE launches, and I think there are quite a few expected broader deployments by the end of the year. What is your take on that investment?
Okay. This is the question for Voice over LTE, whether the investment's worth it. Right now, there are some good reasons for service providers to upgrade their networks to Voice over LTE. These include spectrum refarming, in other words, running voice over only one frequency or one frequency group in where they have LTE. Another would be reducing the number of voice systems in operation. In other words, it's easier from an operational standpoint to run one voice system. In this case, it would be Voice over LTE instead of Voice over LTE and circuit, so reducing the operation burden. And then the third potential reason to upgrade to Voice over LTE might be an improvement in the quality of the voice call, or an improvement in, let's say, the number of callers that could be conferenced in, things of that nature. But from my understanding, just researching the cost of Voice over LTE and comparing it to the potential revenue changes, the cost for voice over LTE, at least today, are not really that different from the costs for the older voice system. In other words, it's not like you can go and invest in a voice over LTE system at way lower cost than you could add a new voice subscriber to the older types of networks. So then the next question would be, do we get new revenues? And if we're counting voice alone, it's unlikely that there'd be new voice revenues from upgrading, from a service provider upgrading the voice over LTE. So this means that there has got to be some other tangible benefits. And what our research is telling us is that the payoff is a long time away to have voice be the only way to recover the investment in IMS infrastructure. So that leads to the need for other sources of revenue that relate to rich communication services such as messaging, location services, and file serving, which has not really rolled out in a significant way. So there's the answer. It's not a terribly great investment for voice only, and we need other services in order to make the investment pay off.
Okay. Let's see. Let's go on to Stefan. Can we come back to you? One of the things that, in terms of the evolution of next generation networks, is the move to Lte Advanced. Can you talk a little bit about what the status is of Lte Advanced and whether you anticipate it's going to create a boost in revenue for radio access network vendors?
Sure. Stefan here. Yes. When it comes to Lte Advanced, I mean, we just got through our 1Q13 reporting cycle, and the short answer is there that we did not recognize much revenue for Lte Advanced at this point. However, we are getting feedback from vendors that they are working on trials of the first phase of Lte Advanced, which would be carrier aggregation. There are trials happening in, let's see, Australia, I think South Korea, Scandinavia, and Russia, and that I know of. There might even be some here in the U.S., and there's supposed to be some commercial revenues for this towards maybe the latter part of this year. So I think but in general, we do see this as an investment for the operators that will pay off and generate significant, of course, throughput improvements. So I think in the next couple of years it will be highly utilized technologies in some of the really high traffic locations.
Okay. Sheen, we have an audience question for you, and that is, what is the justification for microwave versus fiber? I'm assuming that's a backhaul question.
Yes. Yeah, that's actually a very interesting question. In that, how do the operators make these choices on which physical medium to go with? But as far as microwave versus fiber, number of factors. But I think maybe one of the primary is that the cost to lay fiber can be is very high. So in many places, particularly Europe as an example, where there is not a lot of fiber optic infrastructure, or particularly with regard to where the RAN is distributed, it is much more economical to use microwave, where you can create links, backhaul links over the air without regard to anything from a physical medium standpoint. I think that is generally going to be the primary justification of going with microwave over fiber, is the cost of putting new fiber. Now, in situations where there is already a fiber plant or fiber optic infrastructure available, it makes a lot more sense to just use what's there and use the bandwidth capabilities of potential of fiber. We see that in a lot of metro large metropolitan areas that are rich in fiber, or the fiber is easily drawn from existing layouts or topologies. So it's not always clear cut. It tends to be an economics-driven question more than anything else, and it's also very regional specific.
Can you talk a little bit more about that, about differences in regional differences for the technologies that end up getting deployed in backhaul networks?
Right. So I think when we look at the backhaul market from a regional perspective, there have been a number of variables here that has created significant differences in what we're seeing. So I think the first piece of the picture here is that the LTE deployments in the U.S. market here have been well ahead of the rest of the world. And subsequently, we've seen a very large investment in backhaul in the U.S. market, as opposed to some other regions where LTE is lagging or being not adopted quickly. However, as Stefan pointed out, we're likely to see, and Chris pointed out as well, we're likely to see some of that catching up. So one, in the U.S. market, we've seen backhaul investments much higher. It's a kind of a two-pronged set of drivers. One is, of course, LTE, but the second is that the U.S. has generally been a copper-rich area or region in terms of the physical medium. So there's been a transition to fiber there. So that's the copper to fiber as well as 3G to 4G transition. In Europe, very heavily weighted towards microwave, traditionally done on across all voice, all the mobile technologies. So that tends to be the driver there, or a market for microwave. Europe and probably in the Middle East and Africa as well. The Asian market's a mix. In some cases, in some of the very dense population areas or countries, a lot of fiber, so no need for anything but fiber backhaul. Some of the larger markets or larger geographic areas, China, for example, you see a blend of fiber and microwave. So all of these things contribute to the demand of mobile backhaul upgrades, whether it's the RAN evolution or whether it's the physical medium, and then subsequently based on either and or both of those sets of variables, the layer 2 and layer 3 requirements.
Okay, great. Chris, we had a question that comes back to a topic that you touched on, and that is the question of VoLTE and recovering CapEx. And the question is, will VoLTE to be premium services to recover operators' CapEx? I'm wondering if you can just kind of address the question of, we spoke about VoLTE and the need for premium services, and whether that gets them to a point of recovering CapEx. If you could go over that in a little bit more detail, maybe that would be helpful.
Okay. Yeah. Well, what we have seen over the past, let's say, several years in many in service providers in many countries is voice revenues are taking a smaller percentage of the monthly or annual invoices that are sent to customers. So already voice is kind of on the decline, or let's say regular voice, the way we know it today, is on decline. So even if, or it would be difficult to start charging more for it suddenly. So what are the premium services that could be added to a system? These would be things that you see today in over-the-top services. Over-the-top meaning like alternatives to SMS messaging, alternatives to voicemail. There are many you could find on the Android or iTunes stores that are alternatives, and these are exactly the types of premium services that service providers can add and essentially compete with over-the-top applications or services, however you describe them. And so, looking geographically, though, the answer I would give would vary based on the service provider and the country that they are operating in. In other words, in some markets, for instance, some over-the-top services have been banned. In this case, the premium that a service provider could charge for a service that is not permitted by an OTT might be a higher premium, while in more competitive or, let's say, loosely regulated markets, they might get less of a premium or no premium. So what could we charge for? Some of the list of things that could be charged for as premium service might be multi-party video conferencing, advanced messaging, file sharing, location services, things of that nature could be charged for above and beyond like regular sounding voice. And there has been some discussion about high definition voice, but the results are mixed as whether that can be charged for.
Okay. Okay. Stefan, I wanted to come back to you with a question. Small cells have definitely been getting a lot of attention this year. I'm wondering if you can talk about some of the reasons that the licensed spectrum small cell market is maybe growing a little on the slow side. I know a lot of people are expecting a boom, but it seems like so far some of the results haven't quite reflected that yet.
Sure. Yeah, the first thing here might be to clarify that there are several different small cell markets, and they're all growing at different rates. The residential small cell market, along with the traditional public access small cell market, are probably furthest along the technology adoption curve. When it comes to these new evolved small cells, we're talking about these compact, lightweight small cells that have integrated baseband radio antenna and the PA in one unit. We refer to this as the public access small cell market. I guess revenues have been pretty small so far. If we look to the early adopters, the initial focus has been to build out mobile broadband coverage, and the macro base station has delivered the best business case for these scenarios. Then the next step is typically to improve indoor performance and cell edge performance. And we believe that in these cases, the business case will start to look more favorable for small cells in certain locations for these types of deployments. And then, of course, we also have, as we talked about earlier, the small cells in the unlicensed spectrum. They've helped to relieve some of the capacity pressures in the high traffic locations. But then, of course, also, aside from alternative or the availability of alternative technologies, the other aspect here is that this shift to small cells is different than upgrading a macro from 3G to 4G, and it's requiring everyone to think differently when it comes to identifying the right location, site acquisition. This process will be very different, and in terms of backhaul, power, interference with the macro, etc. So there's some challenges, but our feedback suggests that there's definitely no lack of commitment. There is demand. There are many trials, and we expect to start seeing some more commercial revenues in the second half of 2013 and or in 2014, driven both by HSPA and LTE.
Okay. We had a question from the audience. Can you add 2G, 3G, and 4G over Ethernet, and will there be any significant delay issues? Would one of our panelists like to answer that?
Yes, this is Sheen. I guess we're assuming somewhat that this question is related to the backhaul part of the market. Yes, in fact, I think that is, in many cases, combining 2G or the different traffic from the cell towers or cell sites, where you have multiple radio technologies and generations to all consolidate that all onto a single backhaul link. It may not always be the case, but it is very, very possible to do that. In fact, one of the things we see occurring is that as operators move to LTE, they're putting in this intelligent devices, or it's effectively multi-protocol routers out at the cell sites. And what that means is they're able to take in 2G, 3G, and 4G traffic into the device and use a single connection back to the core. There are a number of technologies, synchronization, or kind of a virtual circuit type technology through MPLS or VLAN that enable to keep these the different three types of traffic isolated through the connection. But there are some challenges. It's not always going to be the case. A lot of it depends on the architectures of the networks that exist, the legacy versus the new networks in terms of mobile technologies. But yes, it is very possible to do it, and in fact, an economic reason for going with a fiber-based or Ethernet-based backhaul infrastructure.
Okay. We'll do one more audience question, and that question is, what will be the justification of residential femtocell versus carrier Wi-Fi? Panelists?
Well, okay. This is Chris speaking, and this is an interesting one. The numbers show that let's say the SOHO wireless LAN market, which is kind of, I think, installed in the same place a residential femto cell would be installed. This is a very, very large market. I don't have our tables in front of me, but it's overwhelmingly more popular than a femtocell, than the entire femtocell market that's installed into residences. So we already have, let's say, an empirical study that shows, Wi-Fi is a much bigger market and it's far more popular, and these devices are purchased both by consumers, at retailers or online or whatever, or delivered to them by their service providers as part of the, let's say, the data package that they purchase or whatever. So we have that. I guess a way of answering the question would be to say, let's look forward and ask us what we think. Wi-Fi is today is supported in nearly every smartphone the same way, and there are many variants of smartphones that vary by service provider and geography. So what we have is Wi-Fi is sort of the common radio technology, and as a result of there being very high volume and needing only one kind of radio system, it's highly likely it will be more popular in the future. At this point, there's a relative lack of voice over Wi-Fi technology, however. In other words, you can't expect your phones to make a voice call over Wi-Fi at home, and this seems to be the gating factor. There are over-the-top technologies that can do voice over Wi-Fi, but the service provider community has not embraced these over-the-top type of alternatives or made their own. And that at this point is, as far as I'm concerned, the reason that we have a femtocell market.
Okay. All right. Well, panelists, one more question to wrap up, and that is if you could each talk about trends that you see in the market in the next 2 to 3 years in your respective areas of expertise. Who would like to go first?
It's Chris. I'm happy to address that. So in the core, I'm expecting that many of the control elements that are involved in the service provider core will be available by the vendor community in sort of a software-only version, in other words, unbundled from hardware, and the software will be able to run on top of virtualized environments. Some refer to this as network function virtualization. So that's one trend we expect to be important over the next 2 to 3 years. And actually, it relates. The second area relates to the growth that we're seeing in Wi-Fi traffic over smartphones in the public network. It's likely that service providers will want to monitor their customers' usage of Wi-Fi in a way that is very similar to the customer usage of cellular traffic, and this is likely to lead to a change in where that traffic is sent over. Today, a lot of the Wi-Fi traffic service providers is not run over the packet core, and we expect that in the future a growing percentage will be, and this is going to provide a stimulus to the wireless packet core market. Those are the two things that I see in the next couple of years that are important.
Okay. Sheen, Stefan?
Yeah, this is Sheen. So looking at the backhaul market, couple trends there. I think we'll see ongoing backhaul upgrades. Clearly, the bandwidth and protocol changes are required. I think, though, probably the key thing we'll see in the market is that it's going to be moving around from a regional perspective, in that the U.S. market has gone through its first phase, and the majority of the spend has occurred with the in advance of the LTE. I think we're going to see probably more steady and less explosive growth coming from other parts of the world. So I think that's kind of in other parts of the world, being regionally looking at the European market, Latin America, and then some of the major markets or emerging markets in Asia. The other trends I talked about, I think, are going to continue, but in particular, I think we may likely see an evolution and shift towards even higher capacity in the backhaul networks. And we're kind of going through the first generation where gigabit data rates are being deployed. It's very likely we're going to see more and more multi-gigabit and up to 10 gigabit technologies put into the backhaul network. So that will drive potentially a whole different set of equipment or a new generation of products, and that's what we expect in the coming years.
Okay, great. Stefan, your view on the radio access network?
On the RAN here, yeah. And I think I touched a little bit on this earlier, but basically, I think network monetization, I think that will be a continued, that will continue in the next couple of years. Still a lot of number of base stations that need to be modernized. I think we talked about carrier aggregation. That's most certainly something that we see that will start being adopted in these high traffic locations. And I think, see what else, the use of the unlicensed spectrum to offload from the RAN, as Chris talked about, that will most certainly continue. We have great expectations on that SP Wi-Fi market. The densification of macro base stations will probably justify the marginal improvements more so of going to higher order MIMO. So we might see some higher order MIMO upgrades in LTE, and to some extent also on HSPA. And I think we will see continued refarming of spectrum, both in the 1.8 and 0.9 gig bands, to free up spectrum for HSPA and LTE. And then, of course, we also believe that that you need to start complementing the macro network or start improving the spectrum utilization indoor, but also in terms of cell edge improvements, and these type of small cells in the licensed spectrum will also start happening. So those are some of the key points on the RAN side.
Great. Chris, Sheen, Stefan, thank you so much for sharing your insights with us today. For more information on this topic, please download our special report at rcrwireless.com. And you can also join us next Tuesday, June 25th at 2 p.m. Eastern for our webcast on the topic, where we will continue the discussion of innovation in next generation networks. Thank you.